Hello 3D printing friends. Today on the BB3D channel we're going to take a look at this, the Sovol SV01 3D printer. I'll tell you what I like about it, what I don't, and where I think it could use some improvement. Stick around and we'll get into it right after this. I'm Brian and you are watching BB3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about cool 3D printer upgrades, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're going to be taking a look at the Sovol SV01 3D printer. It retails for about $299 US, although there's almost always a sale or coupon code available to bring that price down. I scored a good discount on it when I got it on Amazon about 3 months ago. I like ordering on Amazon because I have a Prime membership, so most things only take a day or two to arrive. Yes, I'm spoiled. In my defense, though, they've got a pretty generous return policy. Now, we'll talk about the printer specs in just a bit because I'm going to be comparing it to my Ender 3 Pro. For now, though, let's focus on what comes in the box. So, in the box, apart from the printer, you also get the assembly and user guide, a micro SD card and USB card reader, a generous 200-gram spool of filament. With most printers, you get a few meters of filament and that's it. You get some nice ball-end Allen keys. You get zip ties. You get standard issue blue-handled flush cutters. You get a standard issue putty knife / scraper. You get wrenches for the nozzle and you get a spare nozzle. The assembly and user guide includes some basic slicer settings and instructions for Cura. I like using PrusaSlicer, so I developed a profile for the printer using that. I've got a link to it in the description if you'd like to give it a try. When you take the printer out of the box, you'll find, to your great delight, that it's mostly already assembled. The gantry, the upper part of the printer, it comes in the box as a single unit with the Z-axis stepper motors, lead screws, hot end, and all that already bolted on. And the base is already assembled as well with the electronics, power supply, stepper motor, and heated bed already in place. The wiring between the extruder and hot end on the gantry and the electronics enclosure in the base is already connected, which is both a blessing and a curse. On the bright side, you don't have to plug as many things in, but the drawback is you can't lift the top part out of the box without also dragging the bottom part along with it because the two are tethered to each other. But apart from that, assembly is really pretty simple. There are 4 bolts that go up through the lower part of the printer to attach the gantry to the base, and once you've got that done, you'll connect the wires from the electronics box in the base to the motors and limit switches located at various points on the printer. You'll also need to bolt the screen and control panel onto the front of the printer and connect the 2 ribbon cables sticking out of the electronics box to the screen. On my printer, the 2 cables weren't labeled to indicate which of the 3 connectors on the back of the screen that they were supposed to plug into, so I did have to guess at it. The only thing that seems to happen if you plug them in wrong is the screen will light up, but it won't display anything. Switching the connectors fixes it, and I've seen reports that the cables are now labeled to remove the guesswork. And there's a filament runout sensor that you'll need to bolt to the top crossbar, and there's a cable to connect that to the electronics box as well. Then you bolt the spool holder onto the top, plug the printer into power, adjust your nozzle height for an optimal first layer, load some filament, and you're ready to print. Of the printers I own, the closest thing I have to compare it to is the Creality Ender 3 Pro. Now the Ender 3 Pro sells in the $230 to $260 range on Amazon. The Sovol SV01 is typically about $40 more than that. So what does the extra $40 get you over the Ender 3 Pro? Well, for one, you get a larger build volume. The SV01's 280 by 240 by 300 millimeter build volume is a fair bit larger than the Ender 3 Pro's 220 by 220 by 250 millimeter build volume. You also get dual Z motors and lead screws to help keep the X gantry level. You get a filament runout sensor, you get a V6 style hot end, and you get a direct drive Titan style extruder with a 3:1 gear ratio, making it easy to print flexible materials. And you get the same high quality 24 volt Meanwell power supply. But what about buying an Ender 3 Pro and upgrading it to try to match this feature set? Sadly, you won't be able to match the build volume. The Ender 3 Pro is a physically smaller printer. You'd need a direct drive extruder kit for the Ender 3, which includes the mounting hardware, and that's about $35. You'd need to add a dual Z drive kit, and you can get one from TH3D Studios for just under $70. You'd need to get a filament runout sensor, and you can get a kit of parts for that from TH3D Studios as well. There's a $6 adapter board and a $6 sensor itself, so that's another $12. So all told, you're looking at almost $120 to get close to matching the features of the SV01. Subtract the $40 difference between the two printers and you come out ahead by about 80 bucks. And as fun as it is to spend time tinkering on printers, you'd have to spend your time installing those things. Although I will freely admit that I usually like tinkering on the printers, and if you do too, then time spent on upgrades probably won't factor into it. Now let's talk about the firmware. The Sovol SV01 runs the open source Marlin firmware. Sovol complies with Marlin's license terms and makes the source code available for download. Not just a binary file, but the actual source code, so you can download it, modify it, compile it, and upload the modified firmware back to the printer. The Marlin firmware includes handy features like power loss resume, where the printer keeps track of how far it's gotten when printing a file. If you experience a power outage, the printer will ask if you want to resume printing once the power comes back on. But perhaps the most important thing you get with Marlin is safety in the form of a feature known as thermal runaway protection. Thermal runaway protection will shut the printer down if it detects a thermal issue. For example, if the thermistor gets knocked out of the hot end, the printer notices that the temperature is dropping despite power being applied to the heater cartridge. So instead of blindly pumping more current into the heater cartridge, which can get fire-startingly hot in a hurry, the printer displays an error message on the screen and shuts everything off. But of course, this feature only works if it's enabled, and on the SV01 it is. So now let's cover the SV01's features in a bit more detail. First up, safety. So I mentioned probably the single biggest feature that you should want in a 3D printer, and that's thermal runaway protection, and the SV01's got that. But what other features does the SV01 have? Well, it has a 24-volt Meanwell power supply, and Meanwell is a long-time maker of power supplies, and they're generally regarded as kind of a gold standard for power supply quality. And having a 24-volt system means the bed and the nozzle can get up to temperature more quickly than on a 12-volt system. It has two Z-axis stepper motors and lead screws, and the use of the dual Z-axis stepper motors and lead screws to move the X gantry up and down means that the printer doesn't have to rely as much on the V-slot wheels to keep the gantry level. Some printers can have sagging problems when there's only one Z motor because it only supports one side of the X gantry and the other side may sag a little bit. With two Z motors, the motors share the work to lift each side of it. Having dual motors and lead screws also helps keep the X gantry from sinking to the bed under its own weight, which is something that I've had to deal with on single Z motor printers. It has a direct drive Titan style extruder with a 3:1 gear ratio, providing better control over filament feed and retraction. In a Bowden-style extruder system, there's a long filament path from the extruder down to the hot end. And because 1.75 millimeter diameter filament can be up to 1.8 millimeters in diameter while still pretty much being in spec, the inner diameter of the Bowden tube must be at least that size to allow filament to pass through, and in fact, it's usually more. So in Bowden systems, there's more room for the filament to push up against the side of the tube. And because of that, the printer generally needs longer retraction distances to back filament out of the hot end on retraction moves, and therefore longer de-retraction moves to get the filament back into the nozzle. Direct drive extruders have a short, straight filament path from the extruder stepper motor down into the hot end, so they need much less retraction distance. In addition, because of that short, straight filament path, direct drive extruders are much better for printing flexible materials such as TPU. The SV01 includes a large glass ultra base-like print surface clipped to the heated aluminum bed, and the bed has those huge leveling knobs that I like. The glass surface has a pattern etched into it, which really seems to hold filament well, and when printing is finished and the bed is cooled completely, the prints will often just automatically release. Now, I admit I was initially skeptical about this, as I've tried printing on plain glass before and never really achieved success. But this print surface has worked really well for me over the past several months. PLA sticks like a champ and releases when the bed cools. TPU sticks like a champ and continues sticking after the bed cools, and PETG sticks a little less well than PLA. Sometimes I print models with sharp corners and the corners will lift. I've started adding brims to my PETG prints, but I may also try running the bed at 80 degrees C instead of 70 degrees C to see if that helps. The SV01 also has power loss resume. Like other printers running Marlin, the power loss resume feature only works when you're printing from the SD card. This is because the printer writes status information to a file on the card as it prints. When the print job is complete, it deletes the file. So the next time the printer powers up, if it sees that file, it knows that power was lost partway through the print. So it homes the nozzles in the X and Y axes and asks if you want to resume the print. Now this is okay unless the bed and nozzle have cooled completely. See, when power is lost, the printer can't move and that hot nozzle stays wherever it was, slowly cooling, but still melting a little bit of plastic. And when power comes back on and the printer homes the X and Y axes, the nozzle has to be torn from the print in order to be moved. And when I tested this, unexpectedly due to a power outage, I was only on the second layer of a print and right on the edge of it. So when the nozzle started to move again, it tore the print off the bed and dragged it over to the home position, and I had to cancel the job and start over. Now, all in all, I wasn't upset about it, and in fact, I found it funny. I don't think it would have been as much of a problem if the print had been a lot further along. That said, it could be a problem if the bed cools a significant amount before power returns, since, as I mentioned a moment ago, parts will often release automatically from the build surface when it has completely cooled. Now, like the power loss resume feature, the filament runout sensor only works if you're printing from the SD card. Now, I'm almost always printing from Octoprint because I find it more convenient, and so ordinarily I just don't use the filament runout sensor at all, and I'm also not making use of power loss resume either. That said, if I know I'm going to be printing a long print job and I don't have enough filament, I know that I can print from the SD card and run the filament through the sensor instead of printing from Octoprint. But more often than not, I just do my best to make sure that I have enough filament loaded. I've never printed something that needed more than a full spool of filament in one shot. Now, let's talk about this build volume. It is 280 millimeters on the X, 240 millimeters on the Y, and 300 millimeters on the Z axis. And with that, you can print some pretty darn big objects. Remember that desktop trash can video that I did a while back? Well, I scaled that thing up to 250% and printed it out. This thing is 285 millimeters tall. The only thing keeping me from printing it at a full 300 millimeters tall was that the model would have exceeded the 240 millimeter depth on the Y-axis, and I wanted to keep the proportions correct. But in less than 7 hours, I was able to print a usable, standard-sized, put it on the floor next to your desk with a trash bag in it, trash can. And it came out great. Well, now that we've gone over the major features of the SV01, let me put this off to the side a little bit. Now that we've gone over the major features of the SV01, let me tell you what I like most about it. I like that it's almost completely assembled out of the box. You bolt the gantry and the screen to the base, hook up a few wires, and you're good to go. I really like the build volume. Now this is the largest printer that I own, and I really appreciate the ability to print bigger models. Many times I've found that if I want to design a functional or practical print, the thing that I want to print is too large to be done as a single part on my smaller printers, so I have to modify the design to fit smaller build plates. I also like the direct drive extruder. My Ender 3 Pro was my first Bowden style extruder, and while I initially feared Bowden systems, I'd heard they were really bad about stringing on prints, this turned out not to be the case with the Ender. It actually did change my mind about Bowden's, but for my own personal reasons, I just really like direct drive printers, and this one works really well. I also like the dual Z motors. Again, my Ender 3 was my first single Z motor printer, and that took a little bit of getting used to. The X gantry was something I never really had to give much thought about on my dual Z motor printers because they were kept level by virtue of having the motors turn in sync. With the Ender 3, keeping the X gantry level is done by making sure that the V slot wheels are tight but not too tight on the Z axis, and by adjusting the position of the gantry bar by loosening, leveling, and tightening the screws holding it to the wheel brackets. And with the single Z motor system, the X gantry can sometimes sink to the bed under its own weight. It's fixable but annoying, and it doesn't happen with my dual Z motor printers. And now on to the things that I'm not all that keen on. Right at the top of the list is the noise level. This printer is loud. Loud, loud, loud. Did I mention that it's loud? I know this printer doesn't have silent stepper motor drivers on it, but in all honesty, the stepper motors aren't all that noisy. So where does all that noise come from? The fans. The printer has 4 air movers on it, 2 on the hot end and 2 inside the base. There's the 30 millimeter fan on the hot end's heatsink, which is kind of loud and runs the entire time the printer is powered on, even when the printer isn't printing and the hot end isn't hot. And there's the parts cooling fan, which is a 30mm blower. Now thankfully that only runs while it's printing, but it's not quiet either. In the base, there is another non-quiet 30mm blower that moves air around inside the box, blowing it at the main board. And this fan, like the hot end fan, runs full time. And then there's the cooling fan inside the power supply itself. Now, apart from a few ventilation slots, there really isn't any provision for proper cooling airflow within the base. The power supply is completely enclosed within the electronics box in the base of the printer. It breathes in warm air from inside the base, blows it across its components, and then exhausts its hot air back into the base. And the 30mm blower that moves air across the main board is just moving hot air around inside the base. So as a result, the power supply's fan is running more or less non-stop the entire time the printer is printing. And as a result, the printer is just loud. I really feel like something could be done to improve the airflow within the base. For example, cutting vent slots in the base sheet metal where the power supply's air intake resides would allow the power supply to breathe in cool air from outside the base. And a separator between the power supply section and the mainboard section could keep the power supply's hot exhaust away from the mainboard. And instead of having the small, noisy blower pointed at the mainboard, a larger, slower, and therefore quieter case fan could move air out of the base, and with vents cut at the right locations, cool air thus being pulled into the base could flow over the mainboard, keeping it cool. About the only other thing that I really don't like is the position of the filament runout sensor. It's intended to be mounted at the top of the printer, but its output is below the maximum Z height of the extruder's input. And this means that if you're using the filament runout sensor and you're printing something that uses the full height of the build volume, the filament's going to be making some pretty serious turns and being flexed in a rather extreme fashion. I would be concerned about the filament breaking after exiting the sensor, which would sort of defeat the purpose of having used it in the first place. So, have I had any issues with the printer? Yes, no printer's perfect, and the SV01 is no exception. I've had a couple of minor issues with it, so let me tell you about them. First, when I got the printer out of the box, one of the screws from the X-gantry was floating around loose inside the box. I had to figure out where that screw came from and put it back into place. And second, I had a problem with the encoder wheel on the control panel. Now, when you turn the knob on a printer's control screen, you can feel it click into place at certain points, and at each one of those little clicks, the knob is sending a signal to the printer's mainboard to say the user has turned the knob a certain amount, either scroll to the next menu item or update the value they're trying to change. But as I turned the knob, it wouldn't always scroll or update the values. Now, since the SV01 uses the same screen module as the Ender 3, I swapped the Ender 3 screen over to the SV01, and the problem went away, so clearly the issue was with the SV01 screen. I sent a little video of the problem to Sovol, and they replaced the screen under warranty. And finally, there was an omission in the extruder assembly. The filament path from the gears down to the input of the hot end should have a short length of PTFE tube to guide the filament, but this was not in place. I needed to disassemble the extruder, insert a tiny length of tubing, and reassemble it. Again, it wasn't a super big deal, but it did cause a couple of failed TPU prints because without that little piece of tubing in place, the TPU had a little area where it could bunch up instead of being pushed down into the hot end. And as far as issues go, that's all I've run into. So now I want to show you some sample prints so you can see what the printer can actually do. Here is the first thing that I ever printed on the SV01. This is one of the sample files included on the card. It's a larger than usual XYZ cube, and it printed on a raft. I'm not usually a fan of rafts, but I understand why printer manufacturers include rafted files like this. With a raft, you don't have to have a perfect first layer. If this is your first printer and you're not yet good at getting a first layer, a raft is your friend, and it helps ensure that you do at least have a successful first print. Now, apart from the bottom surface where it was attached to the raft, it came out pretty good. And now here's a lineup of my usual suspects, test models. There's a Cali, a standard XYZ cube, a Benchy, and loubie's Aria Dragon. Now, all of these turned out really well. Here's the Cali, and it turned out really good. There's really nothing to complain about on it. The layers look nice and even, and the extrusion is good on it as well. Same for the standard XYZ cube, it looks really good. I have no complaints about the Benchy, it came out really good as well. There's no parts cooling issue or anything like that, and it's just a nice clean print. And here's Loubie's Aria Dragon, and she turned out great as well. So after everything so far, you may be wondering about my opinion on this printer. Well, I like it a lot. My biggest issue with it is that it's just plain loud. If this is a printer you're going to keep in a room you're not usually occupying, then it shouldn't be a big deal. But I'm usually 10 feet away from it, so I just kind of put up with it. Now that said, I have some modifications that I'm planning to make to it, and in particular, I want to implement some of those airflow modifications to the base that I discussed earlier in an attempt to cut down on all that fan noise. But I'm quite happy with the printer overall. It goes together quickly, and it does a good job of printing. And since you can generally pick it up for under $280 and sometimes for around $250, this printer is definitely in the sub $300 printer category, and it's a very good performer. With the SV01, you get a solid feature set that will serve you well. Warranty support is good, but expect to wait a couple of weeks for parts to arrive. There's also a Facebook community built up around this printer, so you can visit there to ask questions, discover interesting modifications, or see what issues other users of the printer may be encountering. And I've got a link to it in the description. So would I recommend this printer? Well, if you have a fair idea of what to expect from a 3D printer, and you're comfortable bolting a couple of parts together, and you're okay with using a Facebook group for support, then yes. I mean, I really like this printer and I use it often. I've printed big things with it, I've printed small things with it, and I've printed squishy things with it. A little TPU Calicat. And it's done a great job with everything that I've thrown at it. So that's the SV01 3D printer. There are links to pretty much everything down in the description. Links to the models that I printed and showed you, links to the Sovol Facebook group and their Facebook page, and a link to the printer on Amazon. Now don't forget to subscribe and click the bell so you don't miss any cool 3D printing stuff. If you like the content that I'm producing and you want to help out, check out the description for ways you can do that. Shopping using the Amazon affiliate link really helps no matter what you're buying, and heck, even just subscribing is a great way to support the channel and help keep me making these videos for you. And if you liked this episode, please give it a thumbs up. If not, give it a thumbs down. But either way, please share your thoughts in the comments. Well, thanks a bunch for watching. Now, I'm going to go print something cool. You do the same, and I'll see you next time.